Hi Bobcats, this is Miss Lee, and this video lesson is on analyzing and interpreting box plots. So we've already talked about the 5 data components that make up a box plot: the minimum, the maximum values, and the 3 quartiles, which the quartiles are all medians, right? And we talked about how to create a box plot using those 5 data components. Well, now we're going to take the data that we see in a box plot and we're going to analyze and interpret it. So please make sure as you're watching the video that you're taking good notes. Okay, now that we know how to make a box plot, why do we even use them? Is it to see individual data? No, of course not. You can't see individual pieces of data just by looking at this box plot. Yes, you know the minimum and the maximum values, but that's really all that you know. Okay, you don't know how many pieces of data are 50 or how many pieces of data are 70, or if there is even a piece of data at 70. You don't know individual data other than the minimum and the maximum. So that's not the reason why. Remember, a measure of spread is a single number that describes how spread out or clustered together the data is. We talked about range. Range is one measure, which is the difference between the largest and the smallest numbers in the data set. Okay, so the range tells you if it's a small range, then that means that all of the data are clustered together. They're really close together, right? They're like elbow to elbow. But if it's a big range, then it's really spread out. Maybe they can stretch out their arms, right? Or there's even more space than that. So there's going to be a larger spread, a larger range, more room, right? More room to move around in. Okay, so look at these 2 box plots and let's identify the range. Again, it's going to be high minus low. So looking here, group A, my low is at 17, my high is at 26, so we subtract the 2 because it's the difference between the high and the low. 26 minus 17 is going to be 9. That's the range for group A. Do the same thing for group B. The low is at 18, the high is at 29, and 29 minus 18 is going to be 11. So one has a range of 9, one has a range of 11. Which one has a larger range? Which one is more spread out? Which one has more elbow room? It's going to be group B because it has a range of 11 versus a range of 9, which is what group A has. That's all the range is telling us. Since we're talking about dancers' ages, then ask yourself, okay, is this a good range to have for ages of dancers? Well, we're going from 18 to 29 years old, which is a range of 11. Is that a good spread for the data of the dancers' ages? I guess it depends on what kind of dancer. I'm thinking like a ballerina, and I'm thinking, well, maybe they can be into their 30s. I'm not really sure. But that's where you just have to kind of look at it and think about it and think about what the data is about. It's about dancers' ages, and then think about the range from the high to the low. Okay, another measure of spread is what we call the interquartile range, or the IQR. The clue words there, interquartile range. So you're finding the range of the quartiles. So basically you're finding the range of the box. So to find the IQR, it's the difference between quartile 3 and quartile 1. So coming back to our dancers' ages box plots, let's find the IQR, the interquartile range. Here, the quartile 1 is at 20 and quartile 3 is at 24, so you find the difference. 24 minus 20 is 4. The IQR interquartile range for group A is 4. For group B, it's halfway between 21 and 22, so we'll say 21.5 and 26. So if you subtract the 2, it would be 4.5. This box represents the center part of the data. Okay, it represents the center. We know the minimum is over here at 17 or 18. We know the maximum is over here on the right side, but the box is the center part of the data. It's the middle 50% of the data. So the middle of the data, the middle of the ages, is actually pretty close for group A and group B, right? It's only 5/10 difference, but it's actually really close. That's the IQR, the interquartile range, the range of the middle 50% of your data. Now, speaking of percents, Remember, the box plot separates the data into 4 equal parts, okay, quartiles. When you think of quartiles, what word do you hear in there? Quarters. And what percent do you know about quarters? 25%, right? Okay, so even though the parts may differ in length, meaning their spread is different, each part, each quartile contains 25% of the data. So going from the minimum to quartile 1 is 25%. Going from quartile 1 to quartile 2, 25% of the data. From quartile 2 to quartile 3, 25% of the data. From quartile 3 to the maximum, 25% of the data. Okay? It doesn't matter how big that range is. It has 25% of the data. If the length of the whisker or the box is short, that tells you that the data is more concentrated in that area. It has less variability. It has less elbow room, right? If the length of the whisker or the box is long, then that tells you that it's less concentrated. There is more variability. There's a larger spread. There's more elbow room. Maybe you can put your arms out, right? Okay, let's take a look at this graph here, this box plot. This is the age of independence. The ages of 56 people who signed the Declaration of Independence on July 4th, 1776 are represented in the box plot below. Okay, whenever I see a box plot and I know I'm going to be analyzing it, I go ahead and identify everything. So I know that this is my minimum. This is my maximum. This is my quartile 1, my quartile 2, my quartile 3, and then I can go and I can put my percents. I know that each part is 25%, so I'm just going to put a 25 here, a 25 in here, a 25 here, and a 25 here. And that just kind of helps me go and make sure that I know all of my parts and I don't get confused. Okay, so the first one is, what is the IQR of the ages of the signers? Again, IQR, interquartile range. This is the range of the box. So the range of the box, it goes from 30, 32, 4, 36 to 50. So it's going to be 50 minus 36, and I get what? 14. So 14 years. Justify it. I show the numbers that I'm subtracting, and I'm going to put, oh, IQR is the range of the box. If it was the regular range, it would be the minimum versus minus the maximum, right? Or maximum minus minimum. All right, make this statement true. The age of 75% of the signers is less than or equal to what? So I'm looking for 75%, less than or equal. Well, I know that this is 25%. Plus this 25% makes 50, and this 25 makes 75. So 75% is less than or equal to how old? 50 years. Okay, so 50 years old. And it's because the first three quartiles, they're each 25%, they make 75%. What percent of the signers were 50 years or older? So I need to find where 50 years is at. So here's my 50 years right here. So we're looking for 50 or older. Older means going to the right. Well, what percent is that? 25%. According to the box plot, where is the least variability in the ages of the signers? So the least variability means the smallest. So let me erase my graph so I can look at it. I know where it's not. It's not in here, whoops, or here. So it's in my box, and it looks like it's this one right here. So this would be from where? From quartile 2 to quartile 3. So quartile 2 to quartile 3. How do we know? Well, quartile 2 is 42, so we have 50 minus 42, and that's going to equal 8. It has a variability of 8. It's the smallest section, smallest quartile of your box plot, so it has the least amount of variability. It's closer together, like elbow to elbow, right? All right, Bobcats, good job.